I'm not writing, well, I'm going to have to write the solutions on the page. So 8, consider the arithmetic sequence 1, 2, 3. Well, in my head, I always do it like this. So A plus D, A plus 2D, etc. Right, the first n terms of this sequence is given by the sum of them equals n squared plus 4n. Okay, so find the sum of the first 5 terms. So we know that something we just put 5 in. So we know that something equals 5 squared plus 4 times 5. And that equals 25 plus 20, which equals 45. So far we don't know A, but we do know that A plus 4D, we know that A plus A plus A plus A equals 45. So we'll ignore that for a second and just stick with this. So 45. Now, the next thing we know is that the sum of the first 6 terms is 60. So find U6. So we know that if we added the 5th term plus something equals the 6th term. And we know that the 5th term is 45, and we know, well, the sum of all the first 5 terms and the sum of the 6th term, 2, is that. So we know that U6 equals 60 minus 45 equals 15. Okay, so how do we find U1 then? So we know that the sum of all the terms, so the sum of the terms is 60, and we know that 6 over 2 times something at the beginning, the A term, or the U1, which is what they call it here, plus the final term, which is 60, plus 15, should all add up to find out what this is. So we'll make that 120, we'll divide that by 6, and that equals A plus 15, and then that is 20 equals A plus 15, so A equals 5. So now we know this is, so now what we know is it goes 5, something, 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 15. 5. There is only some, to be fair, there's only 10 difference, so I think it's going to go 5, 7, 9, 11, 13. But I'm not sure you're allowed to do that. So it then says, so we found U1, U1 is 5. Okay, so U1 equals 5. So hence or otherwise find an expression for UN in terms of n. So basically what they're asking is, what is the nth term of the sequence? And I think I know, based on this, that it is 2n plus, hang on, so go backwards from 5 plus 3. But I've got to prove that really, because I really haven't used enough skills. So we could say that we know that 60 equals, let's think, we could use the 60 equals 6 over 2, and then that's times 2a, which is 10, plus n minus 1 times d, which is the thing we don't know. So that means we know that that's 120, that's 10, is it? So that's 120 divided by 6 is 10, equals 2 times 10, 10, plus that's 3, no, it's 20. plus n minus 1, which is 5d. I apologise because I've just realised that's 3. So 60 divided by 3 is 20. 20 equals 10, so that's minus 10 equals 10, and that's 5d, so d equals 2. So finally, you can actually say using this that, so if d equals 2, and we know the beginning, so it goes 5, 7, 9, etc. So we know that that is actually true, so it's 2n plus 3. Okay, now that's as far as I'm going to go with that. Now the next thing that we need to find out is, considering a geometric sequence, so what colour should we use for geometric? Green. It says Vn, where V2 equals U1. So we know that V2 equals 5. And we know that V4, so the fourth part of the sequence, equals 6, which is 15. So it's something. So each time with a geometric sequence, it's A, then it goes AR, then it goes AR squared, then it goes AR cubed. So that's 1, 2, 3, 4 of our sequence. So what's the difference between V2, I'm so sorry, V1, V3, V4. The difference between V2 and V4 would be AR cubed over AR, which equals R squared. So the difference between 15 and 5 equals 10, rather 15 and 5, in this case we're using proportion, so it's 3, so we know that R squared equals root 3. So I'm assuming the beginning would be 5 over root 3, then we times it by root 3 and we get 5, then we times that by root 3 and we get 5 root 3, and then we times that by root 3 and we get 15, and that would be how it carries on. So the common ratio would be root 3. But then it says, given that V99 is less than 0, what is V5? R. Now what I didn't really notice is when you square root something, it's a plus or a minus. So that could be plus or minus root 3. And it means it is a minus. So literally it would have been 5 divided by minus root 3. Then we times by root 3, that gives us 5. Then we times by root 3 again and get minus root 3. Then we times by minus root 3 again and we get 15. Then we times by minus root 3 again and we get minus root 3, 15, or minus 15 root 3. That is horribly laid out, but that's how that works. Right, and I apologise for using